Good day, everyone. Welcome back to another class. Today we'll be talking on set theory. Want to know the different types of sets and know how to solve set problems. All right. Please stay tuned and let's go straight to the note and see what we have for today. Thank you. Okay, so here we have set. It's set theory. So the set is a well-defined collection of objects or things. A set is usually represented by the symbol. You can see the symbol is a curly bracket, curly braces, and capital letters are used to name sets. Example P, capital letter P, the set is this is equal to your curly braces, even numbers from 1 to 20. Now this means that P is the set of even numbers from 1 to 20. So if you're counting a even number, you're counting even numbers from 1 to 20, it's 2, 4, 6, 8, 10, like that down to 20. That's what it means. Now, elements of a set. He said the elements of a set are the items or things that belong to the set. They are called members of the set. So you can call them elements of a set or members of the set. Now, the symbols is this. This is not E. All right, you can just put it. You can just make it a bit bigger, right? So the symbol, this symbol is used to represent membership of a set. So if you want to know that, oh, this number or this object is a member of this set, that's the symbol to notify, or that's the symbol to denote, to know that this is a member of a set, of the particular set. Now, while this other one that has a strike is used to represent non-membership. So if this particular item is not a member or an element of that set, you use this other one to denote, so it shows that it's not a member of that set. Now, example A, set A is equal to 1, 2, 3, 4, 5, and set B is equal to 2, 4, 6, 8, 10. Now 2 is in set A. You see, 2 is in set A, so we will write 2, it's a member of set A. So when you see 2, a member of set A, it's showing you that 2 is a member of set A. Now 5 is not in set B. As you can see, 5 is in set A and not in set B. So 5 is not a member of set B. That's how to know it. You can see it here. Also, please, I want you to understand the way you understand languages. Now, that's how to interpret it in set. Now, set you don't write, you use these symbols to interpret what you are trying to say. That's what it means. Now, numbers of elements in a set. Now, the numbers of elements in a set is called the cardinal number of the set. It can also be called the cardinality of the set. It is written as n a. Now this NA is talking about the small letter n is showing the number of elements in that set. Now look at an example. Set A is equal to 2, 4, 6, 8, 10, 12. Now the number of the number of the elements in that set is what? 6. If you count 1, 2, 3, 4, 5, 6, we have 6 elements in that set. So the cardinality of that set is 6 because there are 6 members in the set. Now, subset. What is a subset? A subset is a set within another set. A subset is just a set within another set. Maybe a bigger set. Now you divide that set into smaller parts. That's what a subset is. So a subset is a set within another set. Like example, set A has 1, 2, 3, 4 down to 8. And set B has 2, 4, 6, 8. So B is a subset of A. This is because elements of B are contained in A, and A is a bigger set compared to set B. That's why. So now for you to know a subset, it's the symbol this. It looks like a C, but it's not actually a C. Now B is a subset of A. Like I said, sets where you don't interpret it in English language, you don't write in English language. This is how to write if you want to say B is a subset of A. Instead of writing B is a subset of A, you write B, you put the symbol and you write A. It means B is a subset of A. Alright? Now, types of sets. One, we have empty set. He said an empty set is a set without any element. So a set without any element is possible without a set without any element. So a set without a set without any element is called an empty set. Sorry. It can also be called a null set. Either you call it a subset or a null set. Now the symbol is this: you put a zero and put a slash, or you just put the empty brackets. Now, please note, zero inside the bracket is not an empty set because it has one member. Zero is an element. Zero is a number. Zero is an item. Zero is also an object if you want to put it that way. So it has one member in it, zero. All right. Another set is finite sets. Finite, some persons call it finite sets. Finite sets. Now, what do you mean by finite sets? A set is said to be finite or finite if the elements can be counted. For example, you can count the elements in the set, or the counting has a definite end. Now, you can also count a set that does not have a definite end. You can count and count and count and count till infinity, right? Now, example of a finite set is number of students in a class. The number of students in a class, for example, in our secondary school, right, we might have a number of students in our class. So that is a finite set because we can count the number of persons in that class. It has a definite end. We can total it. Another type of set is infinite set. Infinite set. A set is infinite if the elements are uncountable. Now, if you can't count it or the counting does not have a definite end, that is an infinite set. Example of it is positive integers. I know some of us might be thinking positive integers, numbers. We can count numbers. Yes, you can count numbers, but counting positive integers does not have a definite end. You count till infinity. So that's why I gave this example, positive integers. All right. Another type of set is disjoint set. Disjoint set. They said two sets are disjoint if they have no elements in common. Now, if they have no elements in common, it's called disjoint. They are not joined together, right? Now, example, set A has 2, 4, 6, 8, 10, and set B has 1, 2, has 1, 3, 5, 7, 9. A and B are disjoint, yes, because they have no element in common. The elements in A are even numbers, the elements in B are odd numbers. So A and B have no elements in common. Now, equal sets. What are equal sets? Equal sets are sets are said to be equal if they contain the same members. The order of arrangement of the element does not matter. Remember, members element are the same thing in sets, right? I said sets are said to be equal if they contain the same members. The order of arrangement or the element does not matter. Example, look at this. Example, set A has 1 2 3 4 5. Set B has 5 3 1 4 2. So you can see that set A and set B are equal because they have the same element. We have 5 5, we have 4 4, we have 3 3, we have 2 2, we have 1 1. So they are the same. Relationship between sets. We have one, union of sets. The set of elements in set A or B or both is the union of sets A and B, written as A union B. That's the symbol to write for union. Like I said, the set you don't write, you write using symbols. So when you write using symbols, A union B is written as this. When listing the union of two or more sets, it will only require combining the elements of the two or more sets in one common set without repeating any elements. For example, we have A1 set A, we have 1 3 5 7 9 11. We have 1 2 3 4 5 6 7. Now we have 1 and 1. So A union B, we have 1 and 1. We write it. We don't write the 1 1. We don't write. We have double 1 in the both sets, right? So we don't write it. We just pick 1 because they are common. We pick 2. 2 is not in A. So we just write 2. We pick 3 because 3 is in A and 3 is in B. We pick it. 4, we write 4. 4 is not in A, but 4 is in B. We write the 4. 5, 5, we pick 1. We pick 5. 6 is not in A, but 6 is in B. We write it. 7 is in both. You write the 7. 9 is not in B, you write 9, and you write 11 as the last one. So this is what a union set, the combination of two or more sets. It's just the combination of two or more sets, nothing more. Intersection set. Intersection set. The intersection of sets A and B written as A is like an N, right? But this is not an N. Is a set that contains all elements in common to A and B. So the elements that are common to A and B. Now this is an example. We have set A, we have 1, 2, 3, 4, 5, 6. Set B, we have 9, 6, 4, 8, 10, 12. So now A intersection B, what is common here? There is no 1 common, there is no 2, there is no 3, but there is 4 common. We have 4 in set A, we have 4 in set B. So we put down the 4. There is no 5 common, there is no 8 common, there is no 10 common, but there is 6 common also. So we put 6 there. So A intersection B, set A intersection set B is equal to 4, 6. That's how to do it. Complement of a set. The complement of a set written as P prime or P complement is the set of all elements which is present in the universal set but are not in set A itself. Now the universal set is a set that has all elements involved. So we write universal set U is equal to 1, 2, 3, 4, 6, 9, 12. Now set A is 4, 6, 12. Now we said the complement of set A, for example, is the set of elements which is present in the set's universal set but not in set A. So set A has 4, 6, and 12, which is in the universal set 4, 6, and 12. But it has 1, 2, 3, and 9. So complement A is 1, 2, 3, 9 because it's not in set A but is in the universal set. I hope you understand this. Now the universal set is the background set which contain all elements being discussed under each smaller set. So the universal set is the biggest set or the big set, while all other sets are the subset of the universal set. I hope you get it. Okay, thank you for staying tuned, and thank you for the class. Well, in our next class, we'll be talking on problems involving set. We'll know how to solve problems with set. We'll know how to draw a Venn diagram, and all of that. All right. So thank you, and please, if you have any question you want to ask, you can ask your question. All right. Thank you, and God bless you.
Quiz.